We are Team Burnkool from Kent College, Canterbury, and we wish to present to you our unique and innovative vehicle design. The purpose of this vehicle is to collect plastic and reduce both environmental and visual pollution. Due to the coronavirus prohibiting travel, we have all come to fully appreciate the natural landscapes at our doorsteps and therefore are going to focus on these areas near our homes. Without further ado, let me introduce you to the rest of the team. Daisy at the sea, Ellie by a river, and Laura at a lake. I'm Anna, and I'm going to guide you through the design choices that were made. Firstly, Laura, what are some of the key features and reasons as to why we chose them?
The amphibious vehicle will be shaped similar to the box, the size of an A3 piece of paper. It will have a flexible ramp at the front to help funnel plastic into the nets. There is a conveyor belt in the body of the vehicle which ensures unidirectionality of plastic movement so it cannot escape the net. The net itself, made of nylon, is durable and can carry almost 1 kilo of plastic or other recyclable materials. Dual motors allow for the vehicle to change direction, moving tyres independently of one another. The high traction tyres allow for movement over steep slopes, mud and some rocks.
Daisy, can you please outline how the vehicle will clear plastic from the beaches?
The amphibious vehicle will effectively work by scooping up the plastic and storing it in a strong and durable net until recycling can occur. Firstly, you can see that I'm standing at low tide, meaning that the vehicle will have to operate in relatively thick mud, which can drain both battery life and result in the vehicle becoming stuck. We've innovatively overcome this problem through the use of multiple alternative power sources, including solar power, generators, and a powerful yet lightweight rechargeable battery. Also, our tracks have considerable traction and also act as paddles, meaning our vehicle can operate in any depth of water.
Now, Ellie, can you please explain how it will work in rivers?
Firstly, the presence of reeds may cause some problems, but the smooth design of the traction tyres allows for uninterrupted flow through the water. Currents may also pose some issues, however, we plan to work with the flow of water, which is beneficial both for saving battery and improving speed.
Laura, can you please explain the operations in a lake?
Plastic floating within can be collected easily and efficiently, whilst battery life is mostly used effectively. Algorithms would be simple to construct and allow for autonomous operation.
Ellie, can you please explain to us any safety aspects that we had to consider during the design process?
We had to be careful of overheating and fires. High quality materials and electrical equipment easily combats this. Our flexible ramp is also a safety feature and works to divert marine life under the vehicle so it does not get trapped. This is inspired by the Ocean Cleanup project in the Pacific Garbage Patch.
We're going to move on to a project analysis. Daisy, can you tell us some of the things we've learned during this experience?
We've learned about automation and robotics, which some of us had little to no previous knowledge about. We've also learnt to use a computer design program, Fusion 360, in more detail to help display our ideas. But the most important thing was that we have learned to research and discuss passionately a current global issue and ways that we can contribute to fighting plastic pollution.
Ellie, would you like to mention any experiments or unsuccessful designs?
Our original vehicle design had interchangeable paddles and tyres, but we later realised that this would mean it would not work in shallow waters. Our new design of tyre extensions was far more versatile. Also, we intended to have holes in the ramp for sand or mud to slide through. However, we later realised that wildlife could easily become entangled. Furthermore, small plastics would also slip through, and these are ultimately what pose the greatest threat to wildlife.
Daisy, can you please explain to us any problems we had as a team?
One of the main issues with our team was communication. Our school shut down due to COVID-19, which made it more difficult to discuss our design. However, we've overcome these issues by collaborating over video calls, setting ourselves deadlines for when drafts needed to be due, and delegating the sectors.
Laura, is there anything you would change about our approach towards the task or the competition itself?
If we did this project again, we would probably start writing sooner, as we spent a lot of time on our design stage. We would also try and stay in contact more when at school, as this would have saved us a lot of problems when contact suddenly became harder. If we had to change one thing about this competition, it would possibly be whether or not we could build or model our robot, as that would have been really exciting.
That's all from Team Burnkool, and we hope you have a better understanding about our design. For more in-depth details, you can check out our report, STEM, The Tide of Plastic.